Hey guys, my name is Greg Hogg, and if you haven't taken the deep learning specialization, what are you thinking? If you want to get a job in data science and machine learning, the best thing you could possibly do is do the deep learning specialization, and I've said this before. If you don't want to spend that much money, if you're looking for a different certificate where you want to spend a lot of time and a fair amount of money doing it, then go with the IBM data science specialization, and I have the review linked in the description below. But if you're looking to learn deep learning, which you are, and I'll prove to this by the end, if you think you want to learn machine learning but you don't want to learn deep learning, I'm pretty sure you're wrong and you do want to learn deep learning. I'll prove it to you by the end of this video that this is what you want to get for not very much money. So firstly, if you don't want to spend any money, then just audit the course. Okay, you can do it for free. You'd miss out on the assignments that are graded and the certificate, so you can't show it on your LinkedIn, and employers do really respect that certificate, and it probably would help in getting a job. But the most important thing for sure is getting these deep learning skills taught by the right person. And so Andrew Ng, which he's right here, is such an amazing teacher, and I would probably place him first on my list of teachers all time. Is just the way that the material is presented, the way that he says it to you, the way he draws stuff out and is clean with notation. It is absolutely phenomenal, and you will just often understand very complicated things the first time. My friend, they had skipped the first 3 courses and they were learning about convolutional neural networks, and they watched his video and they, for like a few minutes, they said, that makes sense. Okay, like that is incredible. This is super complicated mathematics. At least it could be if it's, taught poorly, except in the end of the day, it's just a bunch of additions and multiplications, really. And so if he says it the right way, you're going to understand that. So Andrew Ng is such an amazing teacher, and it's worth getting him to tell you this stuff. Regardless of if you pay for the certificate or not, these are the skills that you're going to walk away with. Build and train deep neural networks, identify key architecture parameters, implement vectorized neural networks and deep learning to applications. Okay, so it's about neural networks. Deep learning means machine learning with neural networks. And even just the base neural network, which they're going to teach early on, is enough to do pretty much anything theoretically. Okay, and there's improvements upon that so that we can better do stuff like computer vision and natural language processing. But just the base neural network, which is really, you'll find just a bunch of additions and multiplications and then applying a specific function to those multiplications afterwards. Once you do that, you can basically solve any statistical problem theoretically, and it's all about training test sets, analyzing the variance for applications, and understanding the optimization algorithms so that your machine learning algorithm or your neural network figures out what you want it to do, and you can phrase the problem given an input and an output, so supervised learning. If you give it that input and output specific to your problem, it may solve the problem. You may need to do something more complicated like convolutional neural networks, recurrent neural networks, or try some other algorithms. But base neural networks, which they're going to teach you about, can solve pretty much every problem. Now, along with that, they of course teach you the 2 other very, very popular neural network architectures, which is CNN, convolutional neural net for computer vision, and recurrent neural networks for time series problems. So natural language processing, it's time series because, it's a sentence. It has an ordered thing here. It's like the dog went over there. That's not the same sentence as over there, there is a dog. Like those are 2 sentences, but they have different meanings. So it's a time series. Okay, and they say NLP there. Transformer models, so this is actually updated from when I did the content, and I actually might do it again, but they're saying staying very, very modern with this. It's going to be an amazing, amazing certificate for you to get. So here's your buzzwords: ANN, CNN, TF, RNN, transformers, DL, backpropagation, Python, neural network architecture, mathematical optimization, hyperparameter tuning, and inductive transfer. If you are considering the certificate, which I would recommend, employers love this thing. Now, it says over here, it is approximately 5 months to complete. Okay, so my thoughts on that are that it doesn't take 5 months to complete. Quite honestly, I think most of you could probably do it in, I would say, 3 months on average. Okay, so I would expect to pay 2 months, and I would expect to pay maybe another month. Okay, so if that was to be $60 per month, that would be, I'd expect to pay around $150 if you want to get the certificate, which is a sum of money, but it's something that would really help towards your job. People do recognize this thing, and you could definitely consider it. But again, the content that you get regardless is here. So I'm going to go into the courses, neural networks and deep learning, okay? And I've done this course already. I've done the whole specialization already, so I know it's in here. But just to go through it with you, I really like to show what exactly the syllabus is, because you can show it without even looking at it. You can see exactly what they're going to talk about. Okay, analyze the major trends driving the rise of deep learning and give examples of where and how it applied today. Okay, so welcome, and what is a neural network? So basically, without talking from a statistics or mathematical point of view, what is a neural network, as in, why the heck do you care? Okay, Andrew's really gonna get you excited about this stuff, showing the amazing applications and not just the super awesome ones like, self-driving cars. I can talk to my Google Home and it knows what I'm saying. Those are really obvious examples of machine learning making super cool apps, except even if you just want this to get, a machine learning job, it is huge for that. Like, you can use deep learning to solve so many statistical problems that companies, they just don't have the people that know this stuff. You have people forcing linear regressions on things, and the new guys come in and saying, hey, I don't think that this is good enough. Okay, a simple linear regression model is interpretable, except if you know neural networks, which we're going to learn about, then that is what's really going to get you your job. Down here, you have an interview with Jeffrey Hinton for 40 minutes, which is a complete god, okay, one of the guys I really look up to. He was a pioneer of the backpropagation algorithm, one of the few guys that he will mention as well. And they have a very, very cool discussion about how basically your brain is possibly doing backpropagation in itself, which is, is your brain a neural network? Maybe yes, maybe no, we don't really know. It's a really cool discussion, and it's going to get you super hyped about the possible applications of neural networks that people don't even know about yet. Jumping down to week 2 is when you really start to understand what's going on here. So you have binary classification as a problem and logistic regression as a solution. Okay, so that's basically a linear regression, but then you throw in that whatever output that gives into an exponential function that forces it into a probability between 0 and 1. And that is basically what a neural network can do. Okay, so a neural network can be basically a bunch of logistic regressions. Okay, so not just one, but you'll understand basically if you've seen neural networks, they have these circles. So it's like these lines and circles. A circle, that can be thought of as pretty much a logistic regression function, and the lines are just a bunch of pretty much linear regression. It's the same thing that's going on here. Okay, and they'll teach you all about that really cool stuff with gradient descent. Okay, so gradient descent is just the problem of, or a solution method, an iterative algorithm trying to find the best parameters. Okay, so it's just a way to solve for what you're looking for in an agnostic or general way. Already by week 3, you'll jump into the shallow neural networks. So build a neural network with one hidden layer using forward propagation and back propagation. And back propagation is really just the gradient descent part for a neural network, and forward propagation is really just getting your output. So it's whatever the model says that you take this input, what do you do? That is what forward propagation is. It's not too complicated to understand. But going on here, it's going to get pretty confusing, okay? So this is stuff where you're going to want to watch it once, twice, maybe 3 times over, sleep on it once, twice. It's going to get kind of complicated here, but it's really, really worth it, okay? It is really worth understanding exactly what's going on here. A gradient descent for neural networks, it's a very small neural network, except you'll find that even state-of-the-art is not that much different than what is going on here, and it's not that much different than what was going on with the logistic regression or even the linear regression. It's all pretty much comes back to just using backpropagation, gradient descent, to solve the problem. At week 4 of the first course, we're going to do deep neural networks. So basically, everything that you learned before, it's just a tiny extension from here. It's just a little bit of knowledge. And then you get to a very state-of-the-art, at least a very good, there's other better solutions, but a very good algorithm that is going to solve a lot of problems. Just a deep neural network. And we're saying, why do you want it deep? Well, we're going to answer that question. How basically getting your dimensions right. So what exactly is your neural network doing? What are its parameters versus its hyperparameters? And that's basically just parameters is tunable by the model through backpropagation, hyperparameters is stuff just like, maybe I set C equal to 7 before I start the algorithm, but maybe I should have set C equal to 12. That's basically what a hyperparameter is. Unsurprisingly, the reviews of the first course are extremely positive, and go ahead and pause the video if you want to hear what one of them say. Next up, on the second course, we have Improving Deep Neural Networks, Hyperparameter Tuning, Regularization, and Optimization. This is the course that'll stick with you forever, okay? Neural networks, maybe one day we find that neural networks aren't as good as some other type of model, but this will almost certainly exist, which is the idea of train versus dev versus test sets. Dev sometimes called validation sets, if you've heard that. The bias variance trade-off in statistics. So this is a lot of just pure statistic stuff, but not super complicated. It's just kind of, you have to talk about it, and it's like, okay, that makes sense. Basically, the idea for everything here is that you want to fit the data in a good way. You don't want to overfit, and so we're going to be talking about this, why regularization reduces overfitting, which is very, very similar to the idea of variance here, and all about basically making your neural network better, making it fit the data in a way that you want it to, understanding why you would want to do this, and some complicated methods like dropout that are built into a neural network now, at least you can very easily, so that you don't overfit, which all this will make sense when you take the course. On the second week here, you're going to talk about optimization algorithms, okay? So before you'll understand for sure what a cost function is, and you're basically just optimizing this cost function. But how do you do that? Well, you do that with gradient descent. Except, yes, you do, but actually there's a lot more complicated algorithms, and so you're going to talk about, say, mini-batch gradient descent, understanding it, exponentially weighted averages, so this is actually like a forecasting technique, kind of understanding exponentially weighted averages, bias correction in it, so all these types of things, which is just kind of figuring out your optimization function. And I tell you right now, most of the time you're going to choose the atom optimizer, and you don't even have to know how it works. But if you go through the stuff, you will, and it'll be very helpful. In week 3 of the second course, we have hyperparameter tuning, batch normalization, and programming frameworks. Okay, so the most important one by far here is programming frameworks, but from a math point of view, it would be batch normalization, which changed everything, and hyperparameter tuning, how to choose these numbers wisely. Okay, so we're going to talk about all these things, training a softmax classifier, and talking about frameworks, so actual coding and not math, and TensorFlow. So this is where you really get down to actually coding this stuff, so that once they talk about these things, you can go in and do later. You'll be ready for a lot of programming assignments. In the third course, we have structuring machine learning projects. So this is how to build a successful machine learning project and get to practice decision making and machine learning project leader. Okay, and yes, as a leader for sure, but in general, it's just going to be a lot of interview type questions. They're going to ask you like the life cycle of ML, how you'd improve your model from a general standpoint and not too specific necessarily, and it's going to help you a lot to talk about these things comfortably. I'm going to go through this one pretty quickly. So ML strategy 1, why ML strategy? So that is important, and basically he's going to tell you something along the lines of you want to go the right direction the first time so that you maximize your probability of doing something right. Okay, and that could mean something general or specific for your ML model. Just going down a specific decision path, you say, okay, I want to choose this type of model. Well, Andrew might have told you, if you watch some videos here, like looking at these metrics and distributions, then maybe you'd understand that improving your model's performance, you could have done that a lot better by going down a specific path the first time. ML strategy 2, carrying out error analysis. So basically, you're going to be wrong pretty much every time in your model. I don't mean it has 0% accuracy. I just mean it's not going to have 100% accuracy. So carrying out error analysis, when I'm wrong, where I'm wrong, why am I wrong, figuring out why you're wrong so that you can adjust it to get better. It's an iterative process. We talk about transfer learning, which is going to be very important for computer vision. Here's my favorite course because it enabled me to get the job that I have right now, which is a healthcare worker. Okay, I don't go pushing needles into people. I'm not that person. I am going to work at a healthcare place where we are using machine learning to analyze what's going on in your lungs. And we do that by using computer vision or convolutional neural networks, which is a neural network who's designed to understand picture data, or equivalently video data, because that's just a series of pictures. So really they're kind of the same thing. Now, it is so cool, and if you don't know that you like computer vision, I think you might really find that after you take this, that it really sticks with you. And I'm going to show some of the things that I'll talk about, but it's going to be very technical here. In week 1, we have the foundations of convolutional networks, really the foundation of computer vision here. So we talk about computer vision. What does that mean? It means simply getting a computer to see visual data. Okay, it's all it means is our eyes perceive and translate to our brain, or our brain helps figure out what we're looking at. And it's like, okay, I'm going to make decisions based off of what I see. It's the same thing, but doing that solely in a computer and not having a human assist in that, aside from labeling training examples for supervised learning, which is how this works. So that's very technical. Edges, basically, this isn't technical. This is just saying like, okay, I want to understand an edge. So like, okay, like I have a cat ears here. Well, I want a model that can figure out cat ears here, but can also see them here and here. Okay, so those are edges. Padding, striding convolutions, this is all stuff that I'm not going to mention because it's just about computer vision specific to CNN architectures. You'll learn about it. It's cool stuff. It turns out that in computer vision or in CNNs, there's a lot of well-known, already built architectures out there. Okay, and you can go on the Keras or TensorFlow website and you can see and basically download, and you will download a lot, existing models. Okay, so you'll take ones that exist, and that's what this week is all about, which is saying, okay, what do ResNets work? This is just some particular thing that happened in CNNs in around 2015 or so. Okay, Inception Network, like a year later, MobileNet, basically the same time. All these different networks that you might think are a waste of time to learn about. It's like, why am I learning about specific models? Believe me, take this seriously. I actually ended up reading the research papers for, I believe, everything here, and I got a job interview, or I actually got a job offer because I understood all this stuff in a very difficult startup position where it had 3 rounds, and I only got the job, at least a big reason why I got the job is because I knew this stuff really, really well. So it is worth it, trust me. In week 3, we have object detection, which is simultaneously the coolest thing in my opinion and also the most difficult. So not surprising, they go together. Cool often means difficult. So we talk about the basic ideas at first. Localization, basically localizing, like finding it in the picture. Landmark detection, finding specific things. Object detection, which means, okay, we find everything in the picture and draw a box around it is really what we mean. And by everything, we mean, okay, at least all the classes that we know, classes as in car, person, stop sign, green light, yellow light, that kind of thing. We need to understand where they are. So, okay, there's a sign here, there's a person there, and so we're going to run this in a loop constantly. And so this is very fast operation. That's why all of this stuff's very, very important. We need to run all of this very, very quickly so that we can do object detection very, very quickly so that we can have self-driving cars, okay? So all of this stuff is extremely cool, very difficult, and you're going to get confused here, I almost guarantee it, especially when they talk about something like the YOLO algorithm. It's going to be difficult the first time. Go ahead and read the paper afterwards. It's still going to be hard, but it's cool stuff. Finish off this great course, we have special applications, face recognition, and neural style transfer. Actually, neural style transfer is not really that cool. It just kind of changes the style of something. It's a neat idea, but not overly cool. Face recognition, I think, is much, much cooler than that, which is basically, well, recognizing a face. Okay, so how do we build a specific neural network? And it's going to be a convolutional neural network, but a specific one to say, okay, this is my face. That is very important for many applications. Okay, so for maybe if you're going to a bank, something that's going to be implemented very soon, I'm sure, is when you go to tap your card, a lot of companies are going to be making it so that you scan your face and say, I'm actually the person scanning the card. Okay, this is me. So it's a basically yes or no, is this you? Or possibly all of the people, say, in a dance routine. Okay, so if we want a camera to follow specific people, well, we can say, okay, well, I recognize this face. This is Sarah. So we want to follow Sarah. So like, okay, where is she? Know her face at all times. Specific architectures like this are really going to help you out in doing that. In the final course, we have sequence models, and you'll see the word natural language processing here because, again, NLP is a sentence. It is a sequence model. You can think about it as, you know, not as clearly a sequence as like the selling of apples day to day. So like, what did it sell for Monday, Tuesday, Wednesday, or the stock? What was the stock Monday, Tuesday, Wednesday? But Natural language processing, a sentence, that's a time series. It's just, I ran over a dog. Why did I do that? I don't know. It's just a sentence that came out. But that's a time series. We solve these problems using recurrent neural networks, referred to as RNNs. So it's a specific neural network, which is built off the feed-forward normal neural network, but we build models such as LSTMs, which I very commonly use, GRUs, which I don't commonly use, and bidirectional RNNs, which is kind of complicated stuff, but really cool idea. So why sequence models? Well, I just kind of said why. A sentence is a sequence model. There's a lot of other stuff that you might not think is a sequence, but it actually is. So we look through all of these different architectures of RNNs, and we get to long short-term memory, which is a big one, and bidirectional, you know, two directions. So basically, it's confusing. You'll read about it. Okay, so natural language processing and word embeddings is what a lot of you here are going to be very, very excited about. Is natural language processing with deep learning is a powerful combination. So you don't necessarily need deep learning, but you really do. And in modern society, it is going to help a lot. So you use word vector representations and embedding layers so that you have outstanding performance. You really do. It's crazy, including sentiment analysis, named entity recognition, and neural machine translation, and a lot more than that. Okay, those are just some examples, but if you want to learn NLP, this is a really, really good way to get started, just to learn this. And if you're watching and you don't want to get the certification, you just want to learn about NLP, watch these videos and it'll help a ton. Week 3, sequence models and attention mechanisms. Okay, so this is stuff that actually I have not done because they updated this course to include this in here, because you know if they're doing that right now, it is an extremely good idea. And although I haven't taken it, I know from reading it that this is stuff that you really want to learn. They did talk about trigger word detection before, but attention model intuition, attention model, that came out in the last few years, going to be very, very important for staying modern. It's a good idea. Again, something that came out in the last few years is the idea of transformers. So here you go. It is stuff that is extremely important right now. Learn transformers and you'll be even better than me. So the last thing I want to do is add it to my Excel ranking form, which I'll show you now. So here's my ranking form for my certification. So far I've done the IBM and the Google, and IBM got an overall 9.2 and Google got overall 9. Now we review based on relevant skills/tools, so like Python, the neural network models, presentation, so how is the content taught to you? Is it clear? Is it in a nice format and in a good order? Popularity, and this is just me aside, my complete opinion aside, what do other people have to say? It should say a lot. So let me put this field in here for deep learning specialization, and relevant skills/tools is a 10. Done. I don't even have to think about it. I know what's in there. We talked about it. If you want to get a job, if you want to do machine learning research, I don't care what it is, 10. Presentation, 10. Okay. Andrew Ng is teaching the order that the content is presented. What is presented in general, 10 out of 10. Popularity, well, let's take a look. It is very high. It's 4.9 with so many ratings. So can I give it a 10 out of 10? No, I cannot. But here I was giving 0.5s, so I will give it a 9.5 out of 10 because I didn't get 5 stars exactly. So there you go, the average, which is going to be, let me just do it because I don't know how to compute an average. I'm not a statistics student. It's 9.83. Okay, I actually am a statistics student, and I will see you in the next video.